Thank you.
You're most welcome.
Okay, do it again. So mean, so bring in data, import data. You know, Elisa.
Yes, Dr. Kim.
I know your purpose. Let me record and then you're chatting and then later you catch up.
Dr. Kim, actually, Alyssa has a Mac and it's so difficult to get all the instructions correctly. So we just want it so that we can have it later when we want to go back to it. That's it.
Yeah. That case, I will give you assignment.
Okay. All right.
Okay. Anyway, so we make the data project again. Okay, do it a new project and save. So like we did earlier last time, existing, and then find where data. So using browse and then where data set, and then create project, and we can have the Apple would Excel file, and then convert already this one. You know how to convert this Excel file to a CSV file. Then import. So I will make a data file because this is in chapter 3. So chapter 3 first data file. Using that function with the CSV. So I will make data. Oops. 3 -1, then put in this using a read CSV function, and then just you know, the double quotation or the single quotation you can use. Then upload the CSV. This file, import to this file, and then look at this. If this one is import the right, so data 3-day low hyphen, that one, yes, good, 180 data size. So first column age, second column profit, location, vehicle type, and then previous information. So if we want to know, calculate mean of a certain column, if we want to calculate age column mean, then mean, then age at data 3-1. So type that one. So we can do mean, enter, and then data already there, and then a $sign, and then whatever age, okay, enter. Then age mean is 45.88333. So you know, in this data set, I didn't include this one on the PowerPoint. Then in this data set, first column, second column, third column, and so on like that. So we can make one column frame data. So using this function, data 3, 2, put data 3, 1, and only age column. Then we can calculate mean. Okay, let's do it. So make another data set. 3 -2 and put data 3, 1. Where is 3, 1? In that data 3, 1, you know, up there we use $, but when you cut only one column, then using bracket like this, and then comma and age, like a field name or column name. So age, then we can cut like this. So data 3, 2, cut only one column like this. Then we can do it mean. Then data 32, the same. You know, when you cut only one column, then you can use using the same one, 32, put something, then from data 1, 3, 1, and the same. You know, up there, I typed the column name. But if you know the column number 1, 2, 3, 4, 5, then if you want to cut only one, for first one, then type after the comma 1 without type or name, column name in a quotation mark, the same. So data 32, then the same. The first column or using a column name. Okay. Next. Median. You know, just the simple mean is arithmetic middle point, the balance point. But this median is kind of a physical balance point. If you took research methodology or other statistics in a class, then you know median. When we find the median, first we rank data from smallest to largest, and then give rank number, and then among them we can find the place where is the middle point physically. So the middle value in a set of data that has been ranked from smallest to largest, then find the middle, the physically middle point using a formula, then find, then associate value that is the median. But we can do it like this, just the median, and then data set, which one, and then already we cut that data column, so using this one. Either way, so let's try. So median, then first one data. So using the data set, the original data, and then using $, and then age, and then enter. Then 46. You know, this data already sorted from smallest to largest. So 46 here, 46, many. Among them, this is the middle point. And then next one is the median. And then data we already cut. 3 low hyphen, then the same result. Okay. And the next one is variation. So using this variation, we can describe data. So certain data shape is narrow, and then a certain data set wide like that. So wider, that is more variation. So we can use this one range, and then variance, standard deviation to describe data set. So first one is range. Range equals largest in that data set, and then minus smallest. So using just the same, like a max is the largest in data set, age minus minimum in data set 31 age column. And then we cut already 32 and so on, and then data 31 and age minus mean. Why it doesn't work? Okay, then data 31 $, age, enter. 52.
Dr. Kim,
Yes.
your screen is kind of lagging. So could you please scroll a bit up so that we could, okay, that's good. Thank you.
Okay. You know, I'm not sure if your side network or my side network, but probably my side, because my son use internet now. And then I use my son use wired connection, and then I use the Wi-Fi. But then my Wi-Fi like this, the extender. Mine one, I think that one was like 6-year-old, 6-7-year-old. So recently, maybe that one is slow. So I bought, I ordered a new one yesterday, and then I got a moment ago. So maybe, so I try to make it better and better, but sometimes, you know, nothing perfect. Okay, can I go? So next one, Max. Using, we already cut data 32 minus mean. Why it doesn't work? Then data 32 again, and same result. Then next one, range function, data, the original data set, and dollar age. Enter. What the? 21.73. Why is different? Why is different? 21.73. Range. Not 21.73. It's from 21 to 73. So we should calculate. So 73 minus 21. 52. So range again. Then using data 32. Again, 21 to 73. So smallest is 21, largest is 73. So anyway, range is 52. Let's try range data 31. How about profit? From 294 to 3,292. So we can calculate 3,292 minus 294. That is range. So maybe, you know, during this time, maybe the network slow, maybe cut. If you know, network cut, then wait, I will be back. Okay. Okay, next one. Variance. So variance is the average of squared deviations of value from the mean. So how far from a mean? So that is variance. So using variance, VAR, then the same data set. So try this one. Okay, VAR, data 3, 2, 1, and at age, enter 111.1316. That is now variance. Then also we can use variance. Then data 3, 1, 2, and so on. So it's easy. And then next one, standard deviation. Standard deviation is square root of the variance. So using standard deviation function SD, the same. So if we, this class is statistics class, then I explain what is variance, what is standard deviation, and so on. But just assume you know what is the variance and then what is the standard deviation. So just how to get those using RStudio function. So SD, why it doesn't work? And then data 31, the same process. And age, enter. So 10.5419. Then again, standard deviation, data 3-2, the same result. Yeah, descriptive statistics, data description, tedious, and then not fun. Okay, next one. You know quartile, right? Quartile divide data set in 4 parts. So Q1, quartile 1, 2, 3. By the way, Q2 is the same as median, physical point, middle point. So from Q1, lower 25%. Then from Q2, lower 50, upper 50. Then from Q3, lower 75%, and then upper 25%. So quartile, using quartile function, then divide age column data, and then give such probability. So 25, 50, and 75. And then this type 2, if we use type 2, then cut like this, 50, 40, 46, 52.5. If we use type 1, then this one produce like a whole number. Type 6, decimal, and then like 2 decimal points. Type 2, only 1 decimal point. I tried other type, then give a different number, but usually type 1 or type 2, then without type, this one gives 2 decimal points like this. So let's try those. Okay. QUA quantile, this one, and then data 31, dollar, age, and type 2, first one, and then probability. We need multiple probability, so use C and then type multiple like data. And then enter. So quartile using type 2, 40, 46, 52.5. Then I will type everything again. So make copy using Control C and Control V. And then change this one, enter. Again, type. Let's try now. 3. What happened? 3 and 2 are the same result. How about type 4? Type 4, 1, 3, 4, the same result. How about type 3 and type 4? Type 5. Type 5, the same as type 2. And then finally, 6 and 7. 6 is different. I'm not sure why they give like this. So, when we use Excel, then find this quartile, then Excel gave a different number too. So I'm not sure how they calculate like that, but sometimes it's different than using program by program or using the formula we can find ourselves. So regularly we can use this, type 1, type 3, or type 4, the whole number. That is fine. Then without type, just delete type part, and it also works. And then without type, the same as type 7. Okay. Tonight's class shorter than last time. So one more thing left. box plot. Other name is the box and whiskers plot. So using 5 numbers, you know what, 3 numbers, Q1, Q2, Q3, such the 40, 46, and 52, and then the mean, smallest and the largest, mean and max. So 5 numbers are smallest number, Q1, Q2, Q3, and then the maximum number. Using 5 numbers, draw, develop box type plot. Then based on that box plot, we can describe the data shape. So using this box plot function, and then this one is just without kind of the condition, just simple. So draw simple box plot. So P or X plot, then data 31 age. So just a simple box plot. So this is the smallest minimum number, maximum number. So from the data set, minimum is 21, maximum is 73. Median is 46. Now internet is slow. And then Q1 is 40, Q3 is 52. So from this plot, this shape is about like that. If we draw, let me use, can I use, okay, no. Okay. If we draw shape, actually median. It is here, and then distribution looks like this. So if we flip like in a turn, like 90 degree, then looks like a bell shape. So using this box plot, we can explain shape of this data set. And then using more function or condition, make it better. So I draw using the simple. And then we can add the axis name. So y-axis label age. So add the name. So I will type everything again. So copy. Then comma ylab Why it doesn't work? Equal ag, enter. Then we can add this axis name, y-axis name. And then next one, we can add when we add an age. And then next one, from data set, I will show you. Okay, just a moment. The original data, the Applewood data, first column, age, and second column, profit, third column, location, and vehicle type, and so on. So if we want to know, combine the box plot, combine by age and then by location. So by location, what age distribution by. So develop box plot using two variables. So box plot age variable and it's like and. We can read this sign as tilde, tilde. So it's like an age variable and location variable. X-axis is the age. Y-axis is age. So first, first variable is y, and then second variable is x variable. So y variable is age. And the main, the title is age distribution of location. When you type this sign tilde, almost every key, the keyboard has that sign, but some doesn't have. So in case your keyboard doesn't have that key, then using this kind of function, Alt 1 to 6. So Alt key hold and then 1 to 6. Using the number key, then it will give you this sign. You know what? When we use Word, Microsoft Word, then if we need a special characteristic, special sign, then we can use the what is that symbol, then find whatever symbol you need. But sometimes like we use this kind of program, then sometimes we can find the special function or characteristics on the keyboard. Then you may use this kind of key, short key, from you can find the reference from this website. I will show you. Where are you? So yes. So you know this one tilde art 1 to 6. Then if you need like a special, you know what, the ordinary like 0, 1, 2, 3, 4, and those symbols, you can type on the keyboard, regular keyboard. But sometimes, you know, if you need such symbols, then you can type like this. Maybe sometimes we need a double bracket. Where are they? So just you know give you a reference in case you need a special character symbol. Okay, then so let's type this one. Go. So box plot. Data 31 dollar page, then comma. You know where this sign in your keyboard? Do you know where it is? The right upper, just in the lower escape key, and then the bottom like that. And then data. Sometimes I couldn't find that one. And location, by location. Then Y label. What the? Why is that work? Why? Page and main. Oops. Why that function doesn't work? And whoops. What's wrong? Data location. Maybe double quotation. Yeah, double quotation mark problem. So this case, I think only a single quotation mark work. So tile again. Then
Dr.
change.
Kim, single quotation mark also doesn't work. It's giving the same errors.
Why?
I don't know.
Let me check. Data 31 location. Error in short. Most atomic. Most atomic. What does it mean? Why? Do it again. box plot, and data, one, enter, at, age, comma, comma, then data, one, location, and then why it doesn't give this? Yeah. What the? Why? Type language. Double quotation. When I did this one, then it worked. Let me work. What's different? There is no comma.
Yeah, the semicolon is not there.
Yeah, no comma between, between.
Tilde.
Yeah, here. Mistype. Between variables, this comma without comma. I found that. So yeah, good error. And but type again. Let's try double quotation. I will try double quotation work or not. Data 31, age, without comma, tilde, and then data 31, location, and then y, map, double quotation, main. Why it doesn't work now? Yes, work. And then we can specify a color. add color there. Color. Oops. Why? GL should be equal. So color green. So without color, give color green. Then give color different color, green, red, blue, and yellow. Whatever you like. So I will copy. So anyway, single quotation or double quotation work the same. So add color. I will use green. So it's multiple, so we need C, and then open parentheses. Green. Red. Blue. Yellow. Delete. And then we can make better like this. And then as you know, you can export image file or PDF file, or you can clip just copy clipboard, and then you can using paste in a document and so on, or zoom. You can see like this. And then I omit this one. You can specify name of axis. Let's try. So somewhere here, X. So can add an age, location, and name, and so on. So with this box plot, we can explain, in the age group, the middle, middle 50% from Q1 to Q3, similar Kane location, and then Tioniston location. And then, age group also similar. But in Orlin area, age group is higher. So middle is Sheffield, and the middle is higher than this in Orlin, but the age group, the whole age group is highest in Orlin group, and then next, and then this one is wide spread, Sheffield. So using this box plot, we can compare the age group by location. Okay, can you do it? Try using age variable and let me see, age variable and then vehicle type. Can you develop? Looks like this. So using age group and then show age group by vehicle type. So age is Y variable and then vehicle type is now Y variable, X variable. Can you try? So making a box plot like this using age and vehicle type. I will do it. It's very simple. Just copy the earlier one and then change only this location. Vehicle type and Y age is written by vehicle type. Then x-axis, where is x? Here, okay. I'm done. Oops, what the? What's problem? Unexpected symbol. What the? Omit comma. Comma problem again. Last time I added unnecessary comma, but here I omit comma. Yes. You done? This one is not fun. This one is fun. So you can do it using, you know, if you use Excel, it's easy to develop this kind of box plot. But we cannot specify like a color or something like this, customize. So this RStudio or R is better than Excel in terms of develop this charts. Okay, I think so. I just show you how to develop simple from simple one to this one. So sometime you may use this RStudio technique function to develop such I can say a nice chart. So when you do research or when you at your work to make a presentation, if you need such type of chart, then you can, if you have data, such similar data, compare, then you can develop such nice data chart. Okay, any question? Okay, that's all I prepare for tonight's class. Next week, I will show you more the visualization. So earlier we developed the bar chart, and what is that? Histogram, and then pie chart, and then plus this box plot. So next class, I will show you more visualization. So scatter plot and other visualization functions. So this is, you know, in business analytic or data analysis, all are important, important. Among them, first, you know, getting data. Then secondly, how can you convert and describe data? And then using a graphical visualization, how can you show data? So visualization is one of the important parts in analytic. So you know, we can use Excel, we can use R, we can use Python, we can use other like what's that? What is the name of the visualization? Like a Tableau. So using a Tableau, and what is another?
Power BI.
Say again.
Power BI.
Say again.
Power BI.
Yeah. Power BI. Power BI.
Yeah.
BI. Power BI. So, you know what? Power BI and Tableau. The most powerful visualization tool is Tableau, and then secondly, that one, Power BI. But this one, using this R, we can do similar. So if you learn more like a Power BI and then the Tableau, then you can develop charts like a fancy better. So this time, you know, I studied this RStudio. The next step is I'm going to study Tableau. I know some part of the Tableau, but it's like a next Tableau. Okay, that's all. If we don't have a question, then see you next Monday, Wednesday, and Friday. Okay, stop. Always I remind, you know, stopping recording. I know, but sometimes, many times, forget recording. Okay, stop.